Today class we discuss collision-free protocols. So almost collisions can be avoided in the CSMA CD, that is carrier sense multiple access with collision detection. Okay, here collisions are detected by using CSMA CD and collisions are avoided by using CSMA CE. But they can still occur during the contention period. Here collisions are still occur during the contention period. So here contention period means the competition for acquiring the slot within a one group is called contention based group. The competition for acquiring the slot within a group is called contention. So here, although collisions can be detected and avoided using CSMA and CSMA/CA, so they can still occur during the contention period. So the collisions during contention period affects the system performance. Okay, so there are some protocols that resolve the collision during contention period are here Bitmap Protocol and binary countdown. Bitmap Protocol and binary countdown. So first one, Bitmap Protocol. Here, this one is the Bitmap Protocol. So here Bitmap Protocol is a collision-free protocol. So in Bitmap Protocol method, each contention period consists of exactly n slots. See here, 0, 1, 2, 3, 4, 5, 6, 7. Okay, 8 slots. So in Bitmap Protocol method, each contention period consists of exactly n slots. If any station has to send frame, then it transmits a 1 bit in the respective slot. Suppose station 2 has to send the frame. So here it transmits bit 1 in the respective slot, that is place 1 in the this slot 2. Okay, suppose if station 3 want to send the data, so place 1 in the this slot 3. Okay, here 0, 1, 2, 3, 4, 5, 6, 7. There are 8 slots. Suppose station 1 wants to send the data, place 1 in the this slot 1. Suppose station 4 wants to send the data, here place 1 in the this slot 4. So there are two types of collision free protocols. First one bitmap protocol and second one binary countdown. So first one here bitmap protocol. So here bitmap protocol is a collision free protocol. In bitmap protocol method, each contention period consists of exactly n slots. See here, in this example, here this contention period consists of 8 slots. Okay. If any station has to send frame, then it transmits a 1 bit in the respective slot. Suppose in this example, the station 2 has to send the frame. So here it transmits bit 1 in the slot 2. And here in this example, station 1 has to send the data. So place 1 in the slot 1. Station 4 has to send frames. So place 1 in the slot 4. And station 6 has to send frame or data. Place 1 in the slot 6. Station 7 has to send data. So place 1 in the slot 7. That means in bitmap protocol method, if any station has to send frame, then it transmits 1 bit in the respective slot. Okay. So this is bitmap protocol method. Second one, binary countdown. Second collision free protocol is binary countdown. See, in this binary countdown and bitmap protocol, there are no collisions. Okay, these are the collision free protocols. So second one, binary countdown method. So this binary countdown method is used to overcome the overhead 1 bit for binary station. In binary countdown, binary station addresses are used. In binary countdown, binary station addresses are used. Suppose here 4 stations 1, 2, 3, 4. So here we are using the binary addresses. Suppose 0001. So this is the station 1. Next 1001. Okay, 1001. That is the station 9. Okay, and next similarly 1100 and 1011. So these are the 4 stations. Okay, station 1, station 2, station 3, station 4. So 0001 is the address of station 1. 1001 is the address of station 2. 1100 is the binary address of station 3. 1011 is the address of station 4. Okay, so these are the 4 stations each has a particular binary address. So here a station want to use the channel broadcast its address as binary bit string starting with higher order bit. Here all addresses are assumed of same length. So here we see this example. So in this method, different station addresses are ORed together who decide the priority of the transmitting. Suppose here 0001, 1001, 1100, 1011. So these are the binary addresses of stations. So these stations are trying to transmit the frame. These four stations are trying to transmit the frame. Okay. So which station has the highest priority is decided on this OR operation. Suppose here first bit is 0, here first bit is 1, here first bit is 1, here first bit is 1. Okay. So we perform OR operation. So 0, 1, 1, 1, 1, 1, 1, 1, 1. So the result of OR operation of the first bits, that is 1. Next, here second bit. So first we perform here OR operation by taking the first bits, that is MSB 0, 1, 1, 1. So the result is here 1. So whenever there is 1 in the MSB, those having the highest priority. So remaining are discarded. See here, first bit 0. So this one gives up. This station gives up. Okay. So this station not in the computation. Okay. So only 3 are in the computation here. Station 2, station 3, station 4. Okay. So why? Because here this one is having the first bit as 0. So but the result of our operation is 1. So that's why this one is discarded. Okay. So first station gives up. Next, second bit. Here this one is discarded, so this is not counted. Okay, station 1 is gives up. So station 1 is not in the computation. So remaining station 2, station 3, station 4. See here, second bit. Now we take the second bit 0, here 1, 0. Okay. Okay, here second bit 0, here 1, here 0. So we perform OR operation again. See 0, 1, 1, 1, 0, 1. So the result of OR operation is here 1. Okay. So if the first bit is 1, that one is on the only computation. Okay. That is only in the computation. Remaining are gives up. Remaining stations gives up. Okay. So here station 2 and station 4 having the bit 0. So here station 2 and station 4 are gives up. Okay. So these are not in the computation, out of computation. Station 2 and station 4 are out of computation. Only station 3 will be proceed. Okay. So station 3 transmits the data. Okay. Next. So first station 3 transmits the data. Then we compare station 2 and station 4. Next priority, first priority, station 3. So next we compare station 2 and station 4. So here station 2 third bit is 0 and station 4 third bit is 1. So next priority is station 4. Okay. Next we compare next one here station 2. Next last station 1. So first station 3 send the data. Next station 4 send the data. Next station 2 send the data. Next station 1 send the data. So this is a sequence. So this is about binary countdown. Okay. See here in binary countdown, the MSB bits are ORed together. That means OR operation, and station sees the one MSB in another station address and knows that higher number station is competing for a channel, and so it gives up for a current round. Okay. Suppose if it is highest number, then it is in the competition. If it is lowest number, then it gives up. Okay. So that is about binary countdown. So these are the two collision-free protocols, Bitmap protocol and binary countdown. So in Bitmap and binary countdown protocol, there are no collisions. Next one, limited contention protocols. Next one is limited contention protocols. Here, collision-based protocols that is Aloha and CSMA or CD. Okay, here collision based protocols that are pure Aloha and slotted Aloha and CSMA/CD are good when the network load is low. Here, limited contention protocols is a combination of collision based protocol and collision free protocol. Here, limited contention protocol is combination of collision based protocol and collision free protocol. Okay, here collision based protocols are pure Aloha, slotted Aloha, CSMA/CD. Collision free protocols are bitmap and binary countdown. So here limited contention protocol is a combination of Aloha and bitmap. Okay, so here this protocol behave like Aloha when the load is light, and next this protocol behave like bitmap or binary countdown under heavy load. Okay, so this is about limited contention protocol. And next here, adaptive Treewalk protocol is an example of limited contention protocol. Here, adaptive Treewalk protocol is limited contention protocol. That means here, first we partition the group of stations and limit the contention for each slot. Here, adaptive Treewalk protocol partitioning the stations into groups and limit the contention for each slot. Okay, so out of that group only one station can transmit the data. Okay, transmission limits to only one station, that's why limited contention protocol. So out of one group only one station can transmit the data. Okay, limits to only one station, so that's why limited contention protocol. Limited contention, that means only one station is in the computation. Okay, suppose here this one is a tree. Okay, so here A, B, C, D, E, F, G, H are the leaves. Okay, these are the stations. A, B, C, D, E, F, G, H. These are the stations. Okay, suppose here star, C star, E star, F star, H star. That means C, E, F, H wants to transmit the data. The stations C, E, F, H wants to transmit the data. Okay, these four stations trying to transmit the data. Okay, so here slot 0, here slot 0, this one slot 0, that means all stations under slot 0, those are here all nodes under node 0 can try which are going to send. Here the stations under 0 are C, E, F, H. Okay, here slot 0, C, E, F, H. Okay, there is a conflict, that means multiple stations want to send the data, so there is conflict. Okay, so this one is divided into two groups. Okay, this one is divided into two groups. Suppose here 1, 3, 4 A, B, C, D, one group. Okay, and next 2, 5, 6 E, F, G, H, next group. Okay, okay, this one. So slot 0 means complete this one, complete tree. Okay, next slot 1, here this tree is divided into two parts. Here slot 1 means here 1, 3, 4 A, B, C, D. Slot 2, 2, 5, 6 E, F, G, H. Okay, so next one slot 1. So slot 1 here C. Okay, C sends. That means all nodes under node 1 can try. See, slot 1. So there is only one station. So C sends. Okay, there is no problem. Only one station. Slot 1. Next, slot 2. Here, this one, slot 2, right hand side. Slot 2. E, F, H. Here, slot 2, E, F, H. So there is a conflict. Okay, that means multiple stations. E, F, H. So conflict. So once again, this one divided into two slots. Okay, if there is conflict, then that one group is divided into two separate groups. Okay, see here, this one is divided into two slots. That means 2, 5 EF, here 5 EF one slot and 6 GH another slot. Okay, so this slot here slot 3 are EF. Okay, EF. So EF, multiple stations, conflict. Here EF, so conflict. Okay. Next, here conflict. So once again, this one divided into two separate slots. So E is one slot and F is another slot. Here slot 4 E sends. Next slot 5 F sends. Okay. Next, this one. Next slot H sends. Here slot 6 H sends. Okay. So this is about adaptive Treewalk protocol. So if there is collision, that slot is divided into multiple slots. Okay. Two separate slots. Then out of that slot, only one station can transmit the data. See here. This one is divided into two slots. EF is one slot and GH is another slot. See, out of EF, only E transmit first. Okay. Next F. Okay. So this is about adaptive Treewalk protocol. This adaptive Treewalk protocol partitioning the group of stations and limit the contention for each slot. Here, we partitioning the stations into separate slots. So first one, this one is a complete one slot, slot 0. So slot 0, the stations are C, E, F, H. Here, slot 0, the stations are C, E, F, H. So multiple stations C, E, F, H wants to send the data. So there is a conflict. So if there is a conflict, so divide into two slots. So 1, 3, 4 ABCD one slot, 2, 5, 6 EFGH another slot. So this slot, now we take this slot, slot 1. So slot 1 only C. So C sends. Here slot 1 only C, C sends. Next, this slot, slot 2. Under slot 2, there are stations want to send the data EFH. So EFH, three stations. So conflict. Here, slot 2, EFH conflict. Okay. Next, once again, this one is divided into two separate slots. That is 5EF one slot and GH one slot. Okay. So here EF one slot and GH another slot. So EF here, EF one slot. So conflict. Next, here conflict means this one is divided into two separate slots. EF. So E sends. F only one F sends. Next, this slot, slot 6 H. So here H sends. This is about collision-free protocols and limited contention protocol. Collision-free protocols are two types: Bitmap protocol and binary countdown protocol. And limited contention protocol, so it is a combination of collision-based, that is Aloha, and collision-free, that is Bitmap or binary countdown. So this one, adaptive Treewalk protocol, is a example of limited contention protocol. So adaptive Treewalk protocol means partitioning the group of stations into slots and limit the contention for each slot. So that's why it is called limited contention protocol.